طيب بسم الله الرحمن الرحيم. So last time we covered some basic concepts related to networks in general. We covered the concept of the internet and the definition of the internet, the internetworking of multiple networks. We talked about the concept of the edge network versus the core, and then we divided the edge into end devices and access network. We covered the edge computing concepts and some of the research trends in edge computing, including the collaborative caching and all the types of computation related to edge computing. Today, inshallah, we need to cover the access networks. So access networks are the end devices. They access the internet through what we call access methods. So each device needs to have one or more of these access networks in order to gain connection to the internet. So these access methods, they are classified into residential access networks, institutional access networks. Institutional, like if Qatar University مثلا wants to have access at the institution level to the internet, what type of access methods that we need to use in that case? And mobile access networks. Mobile لأن هي ليها صفة خاصة related to mobility, portability, and ubiquity, and so on. So we'll talk about each of these categories of access networks. What are the different methods in each of this category, okay, and what are the characteristics of this method? What type of physical cables can be used? What is the characteristics? Why do we use these types of media for these types of access methods, and so on? So this is the main topic of today. In the book, they cover what we call digital subscriber line. Digital subscriber, it's a technology. It's a very, very, very old technology that's currently it's obsolete. Nobody uses it. They are called DSL or ADSL. Maybe it existed when most of you were not even born, or you did not use it. Because we're old guys, so we know we dealt with that. So I actually removed it because now it's obsolete. But the main idea of these types of technologies in the past, you need to understand that in the past, we used to design the network infrastructure, okay, to fit with a particular application. The network infrastructure is tailored to a specific application. For example, we have the public switched telephone network, which is used for voice calls. And we have Wi-Fi technology for data transmission. Okay? Throughout the time, historically, things started to converge. So right now, we are at the 5G or 6G era. So we started to have convergence, network convergence, which means that using the same network infrastructure, I need to provide diverse set of applications. So we use now the network infrastructure for voice calls, as well as for data, as well as for IPTV. All types of applications now, they can be provided through the same network infrastructure. And this is what we call network convergence. Before that, in the past, we used to have a public switch telephone network, only for voice. Okay? Why am I saying this? Because some of these access methods, the main motivation behind them is the fact that, so we need to have data transmission, right? But we already have infrastructure for a network which is designed for a particular purpose. Okay? So can we, in fact, use the same infrastructure and provide data transmission on top of it? Okay? So this is the motivation behind some of these access methods. So in the past, we used to have what we call cable TV. Cable TV is still a technology that exists in some of the countries, that we have an infrastructure for TV broadcast, not through the satellite as we know it today, and not through IPTV. No, we used to have an infrastructure particularly designed to provide TV services. or TV broadcast. Okay, so we used to call that cable TV. So we use like fiber optic cables and dig these fiber optic cables in certain residential area. Okay, and build a certain network infrastructure to provide TV services. So that infrastructure is designed particularly for a TV. So the idea came that, can we use that infrastructure again to provide some data transmission over the internet? Okay, so that's the first access technology that we want to talk about. So we have what we call the cable modem, and the idea here is that we use coaxial cable. That's why it's called fiber coaxial. So we use a combination of fiber optic cables with coaxial cables. We use a combination of both, and we'll see how. So the idea is that these coaxial cables, they can be used, and we used to use coaxial cables historically for TV. Maybe you have seen this a lot. So in the back of the TV, you always have a coaxial cable, right? So the coaxial cable has some characteristics that we have. مثلا, if we look at the coaxial cable from a frequency point of view, the coaxial cable itself supports a frequency range of up to like 2 or 3 gigahertz. Okay? If you were to broadcast all the TV channels you know about, you will see that it will not even consume 100 megahertz. Okay? So you have TV baseband, so this is for TV broadcast, that will constitute all the channels that you have. And this is maybe like 100 megahertz. Okay? But the cable TV itself can carry more than that, can carry more bandwidth. So you have a room from the frequency domain side, you have a room, okay, which is not utilized in the physical cable. Okay? Type. So the idea now, can we use that room to provide some data transmission? Why not? Okay? Type. What does this entail? Yani, what do we need to do in order to provide that type of data transmission over a TV cable? Okay, that's what we need to discuss. So the idea here is that the data transmission, for data transmission, the idea is we convert zeros and ones into what we call a digital signal, and then we use what we call line coding techniques. Again, people who studied network 2 before, they know what line coding techniques are. We convert this to an analog signal, and then we transmit the analog signal over the line. Okay? Type. So if we transmit this analog signal as is, chances are this analog signal will be transmitted in the baseband, which means that it will interfere with the TV signal. We don't want to do that. So what do we do? حد عارف؟ ها؟ What do we do? The electrical. Huh? What do we do? Shift in the frequency of the, which is what we call a broadband, اللي هو ايه؟ Modulation. So that's why we use what we call cable modems. هنشوف ازاي دلوقتي. We'll see the network architecture, how it looks like. So instead of transferring this signal as is, what we do is that we do some kind of a modulation. We increase the frequency of the signal. So this signal, we shift it in the frequency domain. Okay? So TV broadcast will use baseband transmission, and the data transmission will be broadband. So we'll have to shift the signal in the frequency domain, okay? So that we have no interference between the two. So this range of frequency will be used for data, and this is for TV. Okay, there's no interference. Okay? So if you transmit 2 signals at the same time on 2 different frequency bands, no transference, no interference, no collision, and حلو, صح? So that's the idea. So this way we use the physical infrastructure Okay, but we have to use that trick of a broadband transmission. واضحة دي النقطة؟ So that's exactly what we do. So the idea here بقى إن هو for TV broadcast, remember TV broadcast معناه إيه؟ You have broadcast of set of channels that gets transmitted to all the residential homes. And then أنت at home you switch to one channel, صح؟ But all the channels are broadcast. Why am I saying this? Because this actually promotes our this actually makes sense that we use a broadcast network, which means that the network itself has the nature of sharing the same physical medium, okay, by many residential houses. Okay, in order to visualize this, are written here actually. You have 30 megabits per second downstream. Okay, let's look at the network architecture. So the network architecture now is that all these residential houses, they are connected with coaxial cable. Okay, so each of these residential homes, they have coaxial cables, and all of them are connected on one coaxial cable for the entire district. Why? Because actually the TV, it's actually broadcast. So you have the same signal coming with all the TV channels. It comes here and it gets transmitted to all of them. And it's up to you to fine tune to the channel that you want. Okay? So the nature of the application requires the use of shared medium and broadcast medium to reach to all the residential homes. It makes sense. Okay? Type, what is the issue here? The issue here is that if we use that same infrastructure now for data transmission, now there is an implication. Why? Because if you use the same infrastructure for data transmission, what I want to download from the internet is different from what you want to download. It's different. You have different data going to different houses, صح? Type. If we have shared medium, this means that if data rates here, let's say that the data, so you have 30 megabits per second. حتى احنا we used to use this technology in Canada. I lived in Canada for some time. We used to have this technology, and in the announcement they tell you, oh, you have 30 megabits per second. This was huge at that time, okay? But the trick was, this 30 megabits per second are actually shared for the entire district. So this is the trick that they don't tell you, okay? So at some point, if you try to download a file during the night, chances are you can use the 30 megabits per second. So you will feel that your life is good and download speed is very high. But if you try to do that during the day, good luck. The same file you will download in an hour. Why? Because this 30 megabits per second are actually now shared between the entire district. The same 30 megabits per second. Okay? So that's the implication of using one infrastructure for two different applications. واضحة النقطة دي؟ So using the same infrastructure, where you try to use the same infrastructure for data transmission, but the application is different. So now we got some implication that the infrastructure is actually designed particularly for broadcast application. But internet is not broadcast application. No, what you download is different from what I download. Your applications are different from mine. So essentially, in different parts of the network, we will have to share that data rate, which means that at some point, I will get really bad quality of service, low quality of service. واضحة النقطة دي؟ طيب, so the infrastructure is designed as follows. So you have one coaxial cable that covers a district, and you have different districts that are all connected to a fiber node. Okay? Fiber node. So now this fiber node is coaxial بقى. طبعا we know that coaxial cable has بقى ايه يعني unlimited bandwidth. حد يعرف ال theoretical bit rates for fiber optic قد ايه؟ طبعا الفايبر اوبتكس it uses light طبعا. It uses optical signal. The theoretical limit for fiber is 1 beta bits per second. يعني 1000 terabits per second. And there is no application on earth that achieves more than, يعني as far as I know, يمكن مثلا 1.5 terabits per second, which means that يعني you can carry the traffic of an entire continent on one fiber optic cable. But in order to do that, you have to work purely and exclusively in the optical domain, which is impossible currently. There is no such technology that allows you to use complete optical signal in the entire network. Why? Because optical signals, you have to deal with mirrors and you have to keep it in the analog domain. And there is no device on earth that uses this. Yeah, there are some prototypes that uses, as far as I know, 1.5 to 2 terabits per second maximum. And they have to get rid of these devices, because these devices, they have to convert the signal from signal to optical and from optical to electrical and so on. And while you are doing this conversion, you are losing huge amount of speed. واضح كده؟ طيب, so the different districts, they use one coaxial cable, broadcast, share, and then use fiber node, and then use what we call cable modem termination system, which now transforms or bridges the TV broadcast channels on the internet. Okay, and now you have to split. If you have data transmission, you can filter the data transmission and send it to the internet, or if you have TV channels, you can direct the TV channels to the district. And طبعا inside here there is what we call cable modem. What is the function of the cable modem بقى؟ ها؟ What is the function of the cable modem? هي الايه؟ البرودباند، هي الموديوليشن. If in this residential house, if you want to do data transmission, then data has to be modulated in the frequency domain, has to be pushed in the frequency domain. Okay, so that you don't have any interference between the TV signal and the data transmission. So TV signal uses baseband transmission. Data transmission uses a broadband transmission. So you need to have modulation. Any questions? واضح? Okay. This is the first technology. طبعا nowadays بقى احنا we enjoy الحمد لله يعني we have يعني great bounty. We enjoy بقى fiber to home. Fiber to home is fundamentally different, because this infrastructure has been designed and built around the fact that we need one infrastructure that can be possible for all applications. You will see بقى هنا ان هو point to point, بمعنى there is no shared channel anymore. There is no shared medium, okay, between all the houses. So each house is connected directly to an optical switch, ماشي, or optical splitter. Okay? It's point to point بقى. There is no, يعني طبعا this is shared, but this is optical. يعني you don't have that limitation of shared medium بقى خلاص. Okay? طبعا the architecture is as follows. So you have inside the house, you have what we call optical network termination. This is called optical network termination. And here you have optical line termination. وظيفتهم ان هم ايه? That the function of each of these is to convert the signal from the electrical to optical. And then here you deal with optical signal, and then when it comes here, you convert it back from an optical to back to electrical in order to send it to the internet. واضح كده? Any question?
So, is from electrical to optical?
Yes. So this is at the level of the house. Okay? ما فيش بقى, there is no sharing بقى between these houses. خلاص. يعني when you convert from electrical to optical, the sky is the limit when it comes to خلاص. يعني انت خلاص. يعني there's no sharing, there's no problem. ماشي، لان انت طبعا the bandwidth of optical fiber is huge. ماشي، فsharing here has no implications. Okay. طبعا this optical splitter وظيفته ايه؟ عامل زي يعني احنا we'll talk about two different architectures for this optical splitter. There is what we call passive optical network or active optical network. What is the difference between the two? So that's mainly here, this optical splitter. Passive optical network talks about the fact that this optical splitter is essentially like a hub. I feel hub. Did you hear about the hub? Hub from networking point of view, it's actually a dumb device. It's not smart. It does not, it's a physical layer device that performs nothing but splitting an analog signal on all ports. That's it. Okay? The implication of this is that this optical splitter, على فكرة, has no power. You don't need to plug it into any power. خلاص. It's not. You don't need any power. واضح? It doesn't require electricity. It's just a physical device that it receives a signal and splits this signal to all the ports. There is no energy required in that case. There is no, it doesn't convert from one domain to another. It doesn't need to regenerate the signal. Okay? El hub does not require any power. Okay? Which is good, and that's why I personally think that the technology that we use in Qatar is PON. Why? Because these optical splitters are buried in the manholes. You might have seen that. When they activate the network in houses, what do? Close to your house, you will see like a manhole. So the guy goes into the manhole and connects physically the cable coming from your house to the hub. That's it. He does not provide any power ولا energy ولا أي حاجة. Okay? So the optical splitter here is essentially a hub. Or active optical network. Active بقى لا. Active optical network, this optical splitter works as a switch. As a network switch. Okay? Yes. So in that case, for active optical network, what it does is that inside the active optical network, what it does is that it converts first at least part of the analog signal to electrical. Because it has to do some processing. You cannot process things in the optical domain. You cannot deal with light. You cannot process light. ماشي? But it has to do partial conversion to the signal. And then you send the signal to particular ports and not other ports. يعني you can send مثلا the signal to specific ports, not all of them. It doesn't necessarily replicate the signal. واضح الفرق؟ This is the switch. We studied switch again in network 1 and network 2. So we know the difference between a switch and a hub. ماشي؟ A switch is a smart device, slightly, and smart device. So in order to do this, you have to do certain overhead. You may need to convert the signal to the electric domain, read the header, you know which port you need to send this signal to, and then you send the signal on one port and not the other. That's what's called active optical network. Active هنا معناها it has to do some level of intelligence يعني. Okay? But the implication of this is that it's slower actually. It's not faster, it's slower. Overhead. Because yes, there is an overhead. Any processing has overhead. يعني الهاب أسرع من السويتش. It's faster, صح? The hub is faster compared to the switch. واضحة دي النقطة؟ تمام؟ Any questions? So that's fiber to home. So these are two technologies for residential access networks. ماشي كده؟ طيب for institutional access بقى For an institution we need يعني not bad as a residential house. It's not a single user or it's not a single household. Here we're talking about an institution that wants to connect to the internet. So it's definitely, the requirements are different, right? So the level of service and the level of bit rates and quality of service provided to a household, to a household, is different from an institution level. So QU, what they do is that they have to build an entire network infrastructure as a local network inside QU, right? And then they build what we call an institutional router. This institutional router, we used to call it in network one, حد فاكر? Default gateway. So this is what we call a default gateway. Okay? This default gateway routes the entire traffic of QU to the network of the internet service provider, ISP, اللي هو أريدو, Vodafone. And you may have multiple default gateways, each one is connected to a different vendor, or multiple gateways connected to the same vendor. And then you need to have between the institution and Uridu, you need to have what we call service level agreement. These are usually 100-page agreement that they agree that the traffic has to have all these specifications, data rates, very detailed, very sophisticated agreement. Okay? طبعا this level of agreement for a user, these are the terms and conditions, and as we know, blindly you say, yes, I accept. خلاص. But for institutions, this is a very complicated process. ماشي? Inside the university we have typically routers, enterprise level routers طبعا, which are relatively fast, and switches and so on. Okay? So switches and hubs, we call them physical or data link layer devices. Routers are network layer devices. Okay? So typically, for institutional LANs, we have data rates of up to 10 gigabits per second for Ethernet technologies. 10 gigabits per second. ماشي؟ خلاص؟ Okay. For wireless بقى اللي هي mobile access networks. طبعا this is the predominant technology nowadays. It has all sorts of forms. Very complicated بقى very comprehensive. You have tons of technologies when it comes to wireless. طبعا wireless can be used as access method to access the internet in different formats. So we have Wi-Fi technology for wireless LANs, and we have this in the university. You have this in your house, right? We have it everywhere, in malls and things like that. So wireless LANs or Wi-Fis, these are local area networks. The architecture is usually centralized. You have nodes connected to an access point. We should have one here at least. Should have one access point here in each classroom, right? Yes. So it's a star topology. So you have nodes connected to the access point, right? And this access point connects to a backbone network, which is usually wired. It connects that with the switches and so on. Wi-Fi, طبعا they cover a small LAN, right? A small geographical area. Versus if you have a wide area wireless access, which is من أول بقى 1G all the way to now 5G, and nowadays we're talking about 6G, and even some people they started to work on 7G now. Okay? There are certain different evolution, different advancements in the Wi-Fi domain as well as for wide area wireless access. So in the Wi-Fi domain, nowadays we have speeds that reach maybe several gigabits per second. We have, I think there is technology 802.11 BE. This covers up to tens of gigabits per second on Wi-Fi. Okay. In wider area wireless networks, we have طبعا this requires more sophisticated infrastructure. We have towers and base stations, and these towers and base stations, they cover wide area network or wider range. So one base station can cover up to 1 kilometer or 2 kilometers. So it's not a confined geographical area anymore. You have a very big range for base stations. Okay? So طبعا there is a whole course around the wireless networks, lower wireless communication. There is another course. Maybe some of you went through that. So we studied wireless technologies يعني comprehensively. But طبعا you know the generation اللي هو G1 all the way to G5. 5G now we're talking about data rates of a few gigabits per second. And this is what we use nowadays. ماشي؟ طبعا we used to have what we call WiMAX, but this technology has died. So there were WiMAX and there were other technology called LTE or long-term evolution. LTE is the technology that's used starting from 3.5G, and currently in 5G we're still using LTE advanced, and in 6G we'll still be using LTE advanced. Okay? That's why the advancement that happened in LTE has left actually WiMAX almost dying, and it's obsolete now. So we're not actually standardizing WiMAX anymore. And 10 megabits per second is actually a joke now. We're talking about few gigabits per second. Point to point, huh? Not broadcast, not shared anymore. So in one device, you could have يعني, download speed of around actually 1 or 2 gigabits per second. Okay? ماشي كده? So you can have internet access through one or more of these technologies. In your mobile, you can seamlessly transfer between Wi-Fi and 4G or 5G or later 6G seamlessly, even without you knowing that. So your device can intelligently transfer from one access method to another. Based on certain criteria, sometimes this criteria would be your geographical location, signal strength, the capabilities of your phone. Sometimes there are some phones that does not actually support 5G, in which case you have to connect to 4G, okay, and so on. واضح كده؟ طيب, any questions so far? طيب, I added this because this is a major trend, which is going to be standardized and integrated in 6G. And it started to gain a lot of emphasis actually nowadays. Why? Because satellite communication existed for decades. Satellite communication existed for decades. So we used to have satellite communication 2-3 decades ago. It's not something new. But what was the challenge, and why we're not talking a lot about satellite communication nowadays? Because the problem is that these satellites, they are, of course, deployed in high Earth orbits, right? In very, very far locations, right? So in the past, we did not have sophisticated technology, and the idea is that if you want to have internet access through these satellite communications, a device here has to send the signal all the way to the satellite and then go all the way down to Earth. So this entails what? Latency, right? So the signal has to go all the way to the space and then come back again. So as you can imagine, latency was a nightmare, okay? Yet, they used to sell this as an internet access even decades ago. Why? Because there are some rural areas and remote areas which do not have access to the internet through one of the typical access methods that we discussed so far. They do not have base stations. They do not have wireless Wi-Fi access points. ماشي? They do not have this infrastructure. So how can they have access to the internet? So the only method that was available at that time is satellite communication. Okay? That's why the download speeds and the upload speeds for these types of devices that use this technology was really in the order of 10 kilobits per second, مثلا, or few kilobits per second. Okay? So with the proliferation and advancements in Wi-Fi and 5G, they started to cover, to provide more coverages even for rural areas, right? So the motivation started to fade out because now we can have 5G base stations that cover remote areas more and more, okay? And people started to see that these data rates are not feasible, okay? Until بقى هو يعني some recent advancements happened that revived these types of technologies. Okay? One of them طبعا هو موضوع الأخ إيلون ماسك ده طلع ستارلينك فهو for satellite we have what we call geostationary Earth orbits اللي هو GEO, and we have middle Earth orbits and we have low Earth orbits. So these are orbits, Earth orbits that exist in different distances from Earth. This is in the space domain, okay? So each of these types of orbits, they have different characteristics. The geostationary Earth orbits are the farthest, and hence, using these types of orbits, you incur the highest level of latency going up and down. But the good thing about this, the good thing about these geostationary Earth orbits was as follows. So you have Earth, and you have different types of orbits. Okay? The farthest one is what we call geostationary Earth orbits. So if you were to put a satellite here, okay? طبعا we know that the Earth is moving around itself. I hope we all believe this. Okay? Some people, they don't. Okay? So if the Earth is moving one round every 24 hours, as we all know, right? So the idea is that in the past, we need to have a geostationary, that if you have certain coverage on Earth, you need a satellite that moves, okay, with the same speed around Earth so that it covers the same range on Earth. Right. What is the benefit of this? The benefit of this is that if the Earth is moving with a different speed, معناها you have some devices here which moves and they become out of coverage. Because in the past we didn't have the technology of the handoff and many satellites, and we didn't have that. So it's good that you have geostationary satellites, okay, that cover the same range on Earth and it's fixed. Okay? So that was good. But what is the problem? The problem is that in order to maintain this, you have to have the geostationary orbits, which is really, really far. And the latency is really, really high. Okay? So if you use اللي هو middle Earth orbits, you start to lose that connection. Okay? First of all, you need to deploy more satellites around this MEO or middle Earth orbits, more satellites to cover the entire Earth. Because as you get closer, right, the area gets smaller, right? So you need to deploy more in order to cover entire Earth. Not only that, if you move with a speed different from the Earth, right? So you need to provide what we call handoff, which means that you need to hand off the traffic from one user, from one satellite to another at different times. Yani you cannot maintain the entire communication with one satellite. خلاص. You lose that. So you need to have sort of a handoff, which means that these middle Earth orbit satellites, they need to cooperate and they need to hand off the traffic from one to another. And that requires a more sophistication, more complexity. Okay? But the good thing here is that the latency is reduced because it's closer distance. Okay? And then we have what we call lower Earth orbits. This is where Starlink is deployed their satellites. They use lower Earth orbits. In lower Earth orbits, first of all, you have to deploy more dense constellation of satellites. These satellites need to be very close and many of them. Okay? And since it's close to Earth, the distance is small, so the latency is reduced, which is good. But you need to provide very sophisticated techniques to handle the frequent handoffs between the satellites. Because the traffic, as the car moves, okay, it needs to hand off its traffic from one satellite to another. واضحة دي? You need to hand off to different satellites. Okay? So that requires more overhead and more complexity. That's where Starlink بقى they really يعني they provided like a disruptive kind of solution that revived this satellite communication, and nowadays it's becoming not only about to cover rural areas anymore. People started to leverage it in different applications. One of the very motivating applications is disaster sites. Because during disasters, you don't have أصلاً, the infrastructure is damaged. If you have an earthquake or a flooding or something like this, you don't have an infrastructure. So the satellite communication becomes, the main solution. Okay? But you need high data rates. So that using low orbit Earth, using another disruptive thing, now we understand the difference, but another disruptive thing that came into the picture and made the satellite communication as a possible solution again is the concept of hierarchical architecture. We have drone technologies, and drones can essentially work as flying base stations. Okay? So you can provide communication between ground devices through drones. Okay? So if you have, for example, a World Cup event, and you have high density of people watching a game or something like this, so all of a sudden you need to provision more resources into the network. You have high demands in certain area. So you can deploy these drones to fly over this region to provide more resources and high quality of service during the game, and then you bring it back. Okay? So the drones have become like an edge device to provide an edge layer on top of these devices. This is the first layer, okay? And nowadays we have another set of technologies called HAPS, or high altitude platforms. These high altitude platforms, I think Google and Starlink, and they have all deployed many of these balloons to provide wireless access. These balloons are usually deployed not in low altitude, in stratosphere أصلا, يعني above the atmosphere. You're talking about range of altitudes of 5 to 50 kilometers, which is even further to the atmosphere. It's called the stratosphere range. واضح? So you can deploy few of these to provide another layer of coverage. All of these before the low orbit Earth satellites. So you have the concept of hierarchical communication levels. Okay? So now you have low orbit Earth satellites in high constellation, high density, to lower the latency, and you have the hierarchical concept. So you have drone level or airplane level, and you have the high altitude platforms, and you have the satellites. So you have different layers. واضح كده؟ So this network architecture has optimized the wireless coverage and brought life back to satellite communication as a vital communication technology after it has died many years ago. واضح كده؟ طيب, so this is what we call non-terrestrial networks, or NTN. This is a big, huge level of or area of research now as part of 6G. So NTN is an integral part of 6G now. Not only بقى to cover rural areas, لا, it's an integral part of 6G. To cover حتى on-demand coverage to مثلا dense areas, things like that. واضح? So you have the satellite layer, and we explained that. You have the high altitude platforms, or HAPS, and you have the aerial platforms, which is composed of UAVs and drones. And you have direct to device. So direct to device, so devices can communicate directly to the drone layer or directly to the HAPS, okay? And you can still provide bridging to the 5G infrastructure as needed. So you have, but very few, maybe one ground-based station is enough to connect this hierarchical network architecture to the 5G infrastructure through one ground-based station or two. It's like the access gateway or the default gateway to 5G. ماشي كده؟ So integration with 5G and 6G, and the key use cases includes maritime communication, غواصات or some under the sea communication. They can use طبعا in oceans and areas where you have, it's very, very difficult to have wireless coverage from base station. Base stations are very, very far. So if you are in the middle of the ocean, now you can use these types of technologies. Or in rural areas, or زي ما قلنا in disaster recovery, disaster management sites or something like that. واضح كده؟ اتفضل. اتفضل.
In the case of Starlink, you mentioned they use the LEO, صح?
Right.
Let's say they deploy it above a place where there's like damaged infrastructure or something. They relay the information like to a different country and then use a ground station there.
Yes.
To connect to the network.
Oh yes, absolutely.
And the latency is how? Is it good still?
It's much better compared to using GEO وكلام ده يعني. Now we're talking about milliseconds.
Right.
And طبعا in order to speed up the data rates, they use more sophisticated technology. ممكن الناس بتوع electrical engineering MIMO بقى. They use MIMO technology, yes, اللي هي multiple antennas beamforming. They use all these technologies to try to speed up the data rates from the physical layer point of view. Okay, so incorporating all these technologies together, they can really increase the data rates very close to the normal infrastructure-based data transmission for 5G. And that's why it's becoming now a more vital technology again. ماشي؟ طيب. So that's the topic of access network. So now we need to cover برضو the topic of physical media. For physical media, we have two types of categories for physical media. We have the guided physical media, and we have the unguided physical media. That's not a new topic. For many of you, you probably know this. طبعا for guided media, we're talking about guided media like what? Like copper cables. We studied this in Network 1. Copper cables, UTP, STP. فاكرين ولا مش فاكرين؟ مش فاكرين؟ مش عارف. يعني ايه guided؟ Guided معناها the entire signal is going through a specific direction. What is the other alternative?
unguided.
The signal unguided معناها the signal dissipates in different directions اللي هي ايه؟ wireless. ماشي؟ But even guided على فكرة includes wireless. يعني wireless there is a specific or special case for wireless that's guided اللي هو ايه؟ حد عارف؟ ايه؟ برافو عليك. Laser, infrared, or microwave lengths which works only on line of sight. Microwave lengths, you can have يعني microwave lengths on top of buildings that they communicate using guided wireless energy, point to point. Okay? So they use specific types of antenna that focuses the entire energy in a specific direction. So that's guided. ماشي؟ فكلمة guided معناها the entire signal energy is focused in a specific direction. واضح كده؟ Of course, the natural types of this includes the copper, fiber, coaxial. Okay? Copper, like اللي هو ايه؟ unshielded twisted pair. UTP, so copper, like UTP or unshielded twisted pair and shielded twisted pair. So the idea of twisted pair is like you have multiple small or very thin wires which are twisted together. Okay? Like phone cables or Ethernet cables. Okay? So phone cables, they use what we call Cat3. Usually it's like 4 wires only. 4 wires, each 2 are twisted together. This has been used for quite a long time for telephone cables, for voice cables only. Okay? And then came Cat5. Cat5 is used for Ethernet, which uses 8 different thin wires. Each 2 are twisted together. Twisting that, it has some reason why they twisted this. We don't want to go through the details of this, but there is a reason why they twisted this way. If you want to know, we can discuss. But here, this is how it's designed. Because of these thin wires and the twisting and everything, there are certain limits. So, unshielded twisted pair, they can provide a bandwidth of like few megahertz only. As we said, coaxial can provide up to 1 or 2 gigahertz. صح? For Cat5 and unshielded twisted pair, you're talking about maybe few megahertz only. Okay? Which means that there is a limit, because if you have a specific bandwidth and the signal it has to be transferred over this cable as analog signal, and then the analog signal you have to convert it using line coding the digital signal gets converted using line coding to analog signal before you transmit it over the cable. So this few megahertz entail that the maximum data rates that you can transfer over Cat5 cables is not more than 100 megabits per second or something. ماشي? So there is some kind of correlation. Okay? So, and there is, of course, which is not covered in the book, Cat6. Cat6 بقى is used nowadays for the latest Ethernet technologies. Cat6 uses بقى shielded twisted pair. طب why the shielded twisted pair supports higher data rates? حد عارف؟ What is the physical characteristic in shielded twisted pair that allows it to provide higher data rates?
Less energy dissipation.
Bravo, Alec. Yes. The shielding confines the energy inside the cable. The problem with unshielded twisted pair, because it's unshielded, so the energy dissipates. Okay? So you have certain level of dissipation. So the energy, not the entire energy that you use for transmission, it goes all the way. So the attenuation is faster. The attenuation of the signal is faster. And hence طبعا attenuation is faster معناها the latency, the transmission delay, and everything is lower, and hence the data rates that you can achieve are lower. With the shielded twisted pair, because shielding allows the energy to be confined inside the cable, so there's no dissipation, there's no energy dissipation. So you preserve the energy, and that's why you can reach to higher data rates. With Cat6, which is used as part of the Cat6 is used as part of the of Ethernet, you can reach easily to 10 and 20 gigabits per second using Cat6. ماشي كده؟ طبعا unguided بقى includes radio, and radio includes all the technologies that we talked about, whether it's Wi-Fi or 5G or 6G and so on. ماشي؟ In which case the signal travels in different directions. So coaxial cable, you have two concentric copper conductors. طبعا for coaxial you have one main thick wire in the middle, and you have some kind of shielding around it. But this thick copper allows you to have larger and wider bandwidth. So here we're talking about 1 gigahertz bandwidth, okay? Which allows you to carry more data rates. Coaxial is used typically for baseband or broadband. We talked about this. On a baseband is to transfer the signal without modulation. So we don't need to shift the signal in the frequency domain. معناها يعني the transmission happens as follows. You have zeros and ones. You convert that into digital signal, and then you convert this to an analog signal, and then you transfer this analog signal as is. Broadband talks about we get to this analog signal and then we increase the frequency. We carry that signal on a carrier. Okay? That carrier shifts the signal in the frequency domain, pushes the signal in the frequency domain. So in that case, you can have multiple signals transmitted at the same time without interference. And we talked about the technology used for cable TV, which uses that concept of broadband communication. ماشي? And we also talked about a hyperfiber cable, which is used for cable TV. This is the technology that we talked about. ماشي كده؟ طيب. For fiber optics talks about it's a glass cable, and inside that glass you have a optical signal. So there is an optical source. This optical source is either a laser source. A laser source allows you to have an optical signal that gets sent very, very sharp. We call it single mode fiber, because the laser is very, very accurate, and it sends a very small beam of optical signal to travel through the fiber cable. Or you can have a cheap source like a LED. They are light emitted diodes. These LEDs, they generate optical beams, but these optical beams, we call it multi-mode fiber, because it sends a light signal with different wavelength, and usually the light signal, it dissipates in different directions. So it's not as accurate as the laser. So you have single mode fiber and multi-mode fiber. طبعا the fiber optics are very, very high speed. So nowadays we can reach طبعا more than that. So the book is not updated. Nowadays we can reach more than that using fiber optics. ماشي? But the theoretical limit of optical is not achieved until today, and not even close. We're talking about 1,000 terabits per second. Nobody has ever achieved that. ماشي؟ طيب. طب radio, in that case we have, as we said, we have the terrestrial microwave and Wi-Fi technologies. You have Wi-Fi technology, 11 megabits per second. This is what we call 802.11g. This was the technology at that time. Nowadays, we have 802.11be. This is the latest one. Okay? In BE, we're talking about tens of gigabits per second. Tens of gigabits per second, okay? Using wireless. And that uses MIMO, uses very sophisticated physical layer techniques that allows you to get to these rates. طبعا after 3G, we have 3.5G, we have 4G, we have 5G, and nowadays we're talking about 6G, which is going to be standardized maybe in a few years from now. And people started from now to work on 7G. Okay? طبعا 6G is going to be completely AI native. AI is going to be built in as part of 6G. We're talking about technologies like NTN, non-terrestrial network. It's going to be part of it. In addition to other types like software-defined networking and other technologies, which is going to be part of 6G. Yeah, and I'm just throwing some terms in case you are interested to take some of these areas as an area of research for your future research. And we talked about wireless, okay? We also talked about wireless. طبعا for J stationary, we're talking about a delay of around 300 milliseconds. This is huge. This is huge. So this allows you to have data rates in the range of tens of kilobits per second, which is currently a joke. But طبعا with the latest technology, now we are getting hundreds of megabits per second. Okay? And in any location on Earth, which is currently it's of big value now. ماشي؟ طيب. Can we have yeah, I think we have time to eat. طيب, we'll continue the discussion. We'll cover the core network. For the core network, this is the backbone. And in core network, there are يعني very fundamental two concepts which we need to cover. We covered them again previously in network 1, but here we want to cover it from a probabilistic point of view. So we need to do some probabilistic performance analysis. We're going to go deep a little bit. So we will cover circuit switching and packet switching. Okay? You should know the difference between the two, but I will go through it quickly. So how is data transferred through this core network? Okay. Again, as I said before, in the past, we used to have this core network designed for a particular application. Okay? That was the concept in the past. So for example, we used to have what we call public switched telephone network. In public switched telephone network, these are potentially switches, physical switches. Okay? And we used to establish the connection end-to-end between two calling parties by establishing a dedicated circuit between these two. Okay? So there is a dedicated there is a dedicated circuit inside the core network specially for this call. And this gets facilitated and established through these physical switches. You didn't live these days. Okay, so this was like 30 years ago and more than 30 years ago.
And the switches used to be manually, like compulsory.
Yeah, sometimes, yes. In some cases, it's manual, yes. Yeah. In the past, we used to hear a voice. طبعا, we don't have this message anymore. All circuits are busy now. Please call again later. Well, we never hear this message anymore. Why all circuits are busy now? Because the circuit has to be established physically between these two entities. So there is a possibility that you call a person, right? I establish the circuit, and then you put the headset and leave, and not actually say anything. So what's happening now is that the circuit is established, okay? It's consumed, and it's not used. Can you see the issue here? Okay? But on the other side, when we establish a dedicated circuit between this and the other one, what's good about this? If there is any benefit. What's good about this? I'm establishing a circuit dedicated for this. What's good about this?
It cannot be disconnected, no interference.
Bravo عليك. No interference, okay? No contention, right? Because the internet nowadays, it may suffer from, people contending on the network. So that's why you see your bit rates, they fluctuate. It's not fixed. صح? It's not staying at a certain level throughout the day. It goes up, it goes down. Why? Because the infrastructure is actually shared between potentially hundreds of millions of users. Okay? And depending on the demand, sometimes it goes high, sometimes it goes low, right? Sometimes there is a router out of service and it damages traffic in a certain area, things like that. صح? So the only good thing about it is that when you establish this dedicated circuit, the performance is deterministic and expected. So if I call a certain person and he accepts my call and we establish the circuit, it doesn't happen that the call during the talk it goes down, or I hear his voice مثلا fading. صح? It doesn't happen, or disrupted. Okay, what's good about circuit switching is that it's dedicated circuit, right? So it guarantees the performance, but even if you're not using it, it's consumed. This is bad, the real issue. But what's problematic about this? It's not scalable. It's not scalable. So if more than 100 people are making voice calls, the person number 101 cannot make calls anymore. Okay? And that's not scalable. This is not scalable. As we said, scalability is I can add users with some guarantees that the existing users will not be affected.
Keeping the same quality.
Yes, keeping quality of service at a certain level. So in circuit switching, it's not so scalability cannot be maintained. This is the fundamental issue. Okay? واضحة كده؟ طيب. Packet switching, packet switching I'm not dedicating a circuit anymore. So for circuit switching, first there is a phase called a circuit establishment. That's an overhead that I have to go through. I have to dial a number and you have to accept. When you accept, all the switches in the middle, they will have to be notified and establish the circuit end-to-end. ماشي? So there is an overhead to establish this circuit end-to-end. That's a significant overhead. Okay? The implication of this, performance is guaranteed, but I'm consuming this circuit even if I'm not using it. And that's a big issue. ماشي؟ طيب, in packet switching, in packet switching it's different بقى. You have many users, okay? They are sharing the core network. ازاي? Each user converts his traffic into set of packets. That's why it's called packet switching, right? And these packets, they get multiplexed on the network infrastructure. Okay? There is no circuit establishment. The packets, they can go they can take different routes inside the network. خد بالك, this pipe represents a network which contains routers and switches in the middle. Huh? It's not like physically a pipe. Yeah? This is a representation for a network core. Okay? So this network is shared statistically between these users. What does that mean? This means that these packets, they get multiplexed inside the network. Now, what is the implication of this? The implication of this is that one user can take the entire bandwidth of the network at an instance of time. which means his traffic will go very fast, with the condition that other users are not sending anything at this point. Okay? Now there is no circuit established. ماشي? If multiple users send their packets at the same time, they will share the medium, صح? Okay? They will share that medium. Okay? So their packets will go, depending on the capacity of the network, they may go together, but in different routes مثلا. Okay? They might arrive unordered, they might take certain routes, but one further implication, they may get lost. صح? I cannot guarantee the performance. That's why on the internet nowadays, the IP or most of the routers, they provide service called the best effort. So I will do my best to transfer the packet, but I cannot guarantee 100% they will be delivered. So they may take different routes, they may get lost, they may go into circles in the network. Okay? All scenarios are possible. You're not establishing a circuit. If you're establishing a circuit, that's a pipe. If you throw water in a pipe, it will go smooth to the end, صح? But there's no pipe. Okay? So you have a network core, the packet can go anywhere. ماشي؟ هتقول لي ما this is not efficient. لا, this is scalable. This is more scalable. This is more efficient. Why? And we'll see now. لا تفضلي. صح صح ما هو يعني خدي بالك when you increase the number of users it does not affect the other users as long as you can maintain certain level of quality of service. There is no such thing called infinite scalability. بس هنشوف بقى ازاي this concept it's much more scalable compared to circuit switching using بقى some statistical evaluation. We'll see بقى يعني we'll calculate some probabilities.
Can you mention sometimes the packets may not arrive or
Yes.
or
Yes.
unordered or whatever? Doesn't it depend on the network protocol?
Of course.
Now, like let's say we're using TCP, then they must.
Of course. I'm talking about from the. No, that's why we have protocol level. Okay. Some protocol level they provide guarantees. Some protocol level they do not provide guarantee. But هو TCP provides guarantees based on what? هو قال لك إن الباكت لازم توصل؟ لا. هو قال لك if the packet does not arrive, what I will do? Retransmission. طب هو ده you're not fixing the fundamental problem. Packet did not arrive. You will retransmit ماشي. طب ما هو that's natural. But in circuit switching, you will not need to retransmit because packet is guaranteed not only to be delivered with guaranteed quality and ordered كمان. ما هم they are going through a pipe. ماشي؟ واضح كده؟ So in packet switching, we discretize data into packets, and then packets will be multiplexed, okay, statistically. طبعا in addition to this, in order بقى to maintain some quality of service, routers in the middle, they have buffers. They have memory buffers, okay? So if you send so many packets on the network, okay, it will be stored. That's why in internet we have the concept of store and forward. We'll talk about the concept of store and forward. ماشي؟ طيب. So this is the circuit switch. Circuit switching talks about establishing, and when I say establishing a dedicated circuit, it doesn't necessarily mean a physical circuit. In PSTN, it used to be a physical circuit. معناها there has to be a port available, physical port available, okay? But I can do circuit switching on the internet, okay, by establishing logical circuits. Logical circuits, okay? There is a protocol called MPLS, if any of you heard about it. it establishes circuit switching or dedicated logical circuits on the internet. ماشي? So if you have, like for example, if you have physical network, whether there are routers or something, I can divide this network in logical pipes like this. Each pipe has fixed thickness, okay? And I have certain number of pipes, and we will see what kind of communication paradigms that support this. Basically, اللي هي FDM, TDM. I can divide this channel either in the time domain or frequency domain into fixed pipes, logical pipes. Okay? So your transmission goes through a fixed pipe. So in that case, you are guaranteed the data rates. There is no interference. There is no collision. Your performance is guaranteed. ماشي كده؟ ماشي? So this is the main advantage. But in order for you to do this, you have to do a code setup. You have to have the overhead of circuit establishment. So you have to assign a physical channel, whether FDM channel or TDM channel, to a particular user throughout end to end. Okay? So that's a code setup or a circuit establishment that I have to go through. ماشي كده؟ طيب. If you do this, then you have the benefit of dedicated resources. There's no sharing. No multiple users will share the same circuit. خلاص. Okay? Which means performance is guaranteed. But what is the cost? Not scalable. Okay? So in order for me to do this, I have to divide the resources in the network into deterministic pieces, whether in the frequency domain or the time domain. ماشي؟ يا إما frequency division يا إما time division. طبعا in certain technologies like in wireless, we have برضو a code division. بس يعني this is another thing. There are different spaces. درسنا الكلام ده في wireless communication. If any of you took the wireless communication. So there is another third domain called the code division. Code division multiple access. ماشي? So there's frequency division multiple access, time division multiple access, code division multiple access. ماشي? So the resource, once it's assigned, it's dedicated, even if you're not using it. This is the problem بقى. ماشي? And we'll see this using some calculations. So this is frequency division multiplexing, and this is the time division multiplexing. So the time is divided or the frequency is divided. Very straightforward. But what is the advantage and disadvantage of each? The time division multiplexing, the transceiver اللي هو الترانسميتر والريسيفر from both sides, it uses one frequency range. صح؟ One frequency. It uses one bandwidth. But it divides the bandwidth into في التايم مش في الايه؟ مش في الفريكونسي. طيب. So it's one bandwidth only. So the transceiver design usually is a little bit simple هنا. So the transceiver is a simple transceiver design. But so not يعني very simple. ليه? Because there is an issue here that I have to deal with, which is حد عارف؟ لا. أيوة اللي هو synchronization. Because each user now has to transmit exactly in his time slot. And we're talking about different users. يعني if I tell you what time is it now with you, chances are I will find different times, صح? Imagine these different users, they are trying to synchronize their time slots. They are sending in their time slots. So definitely there might be some overlap. We call it overlap, مش interference في الحالة دي. We call it time overlap. We call it a time overlap. ماشي؟ فsynchronization here is very key. So in TDM, synchronization is an issue. In FDM, what is the issue here? The issue here is that the transceiver has to deal with multiple frequency ranges. So this complicates the transceiver design. واضح كده? So these are the issues, the pros and cons. But in all cases, they both provide deterministic way of how you divide the channel. And performance is guaranteed. So if I tell you now, this is the exercise, huh? So how long does it take, okay, to send a file of this length, ماشي, of bits from host A to host B using circuit switched network, ماشي? The circuit speed is 1.536 megabits per second, but this is the whole pipe length, the thickness of the entire pipe, huh? But these are divided into 24 time slots. ماشي? And there is 500 millisecond overhead for establishing the circuit. What is the actual total time بقى? So first, I have to go through the circuit establishment. This is an overhead, and this is given. So the time equals to, first, 500 times 10 to the power minus plus. Now I have to go through this. It's 0.5 seconds. I have to do it. Okay, plus. Now I need to transfer a file of length 640K, okay, on a channel. What is the effective bit rate of the channel that I'm using? Huh? At least you need to answer this. 1.5? Divide by 24. Yes. Well, that's simple, yani. So I have an expected throughput on the channel of 1.536 times 10 to the power 6. This is divided by 24. Okay? How do I calculate the total duration, low transmission time of this entire file? The transmission time, what is the transmission time? Transmission time is defined as the length of the packet divided by the rate. صح? We studied that in network 1. صح? So this is 640,000 divided by this. So this is the total time. So 500 milliseconds circuit establishment plus L over the so خد بالك بقى. Here I'm transferring a file of this length over the time slot. Because of circuit switching, there are issues here. First, I did not have the luxury of using the entire bandwidth for my own traffic. صح? Although maybe the other 23 users are not sending anything, but I did not have this flexibility. At the back? That's an issue. What is the other issue? I may not be sending the entire file all at once. Maybe I will send part of it and then stay idle. برضو my channel is not consumed. Okay? So in order to appreciate this even more, we have another similar example for packet switching, which will give you more motivation why packet switching is actually more efficient and more scalable. For packet switching, I have each end-to-end data divided into packets. زي ما قلت. These packets, they get multiplexed on the core network. Okay? If one user is sending at one instance of time, he may get the entire bandwidth for his traffic. If many users are sending, now the capacity of the physical link is divided between the user in a similar way like circuit switching. But even if the capacity is high and the congestion is high, there are other factors that I can use to deal with congestion. One of them is buffering the packets in the routers. ماشي? So I can even overcome to send traffic with higher rates than the capacity of the link. كل اللي أعمله إيه؟ I will buffer and I will send one at a time. And I will keep buffering the other packets in the buffer until I finish the transmission of the others. واضحة دي؟ So we'll study an exercise that will give you more understanding to this. So this is bad, the disadvantage. The disadvantage is that if the demand exceeds, I'm going through بقى what we call a congestion. خد بالك, not collision. There's no congestion. Why am I saying congestion? Collision happens that two signals, they collide, both of them are gone. But here nothing is gone. Inshallah, مفيش يعني. So if you have many packets, some of them will get buffered in the router. We call this congestion. The buffer of the router will start to build up. ماشي? We call this a state of congestion. ماشي? So congestion is when the packets are queued inside the buffer of the router. And in all cases, I'm using what we call store and forward. Store and forward معناه إيه؟ خد بالك, each packet, when I transfer the packets over the physical medium, what do I have to do? These packets, they have to be converted to analog signal. واضحة دي? So at each router level, so I have a physical medium, let's say copper, coaxial, fiber, things like that. And then I have a router. And then I have another medium, could be wireless, anything. And then I have another router. ماشي? This might be slightly different from if I use a switch or if I use a hub. Hub does not have store and forward. Store and forward معناه إيه? Store and forward معناه the packet will travel through the physical medium as an analog signal في الآخر. Okay? When it gets to the router will have to store it. In order to store it, we'll have to convert the analog signal back to digital. Store it in a buffer. Okay? And then process the packet and then convert it back to electric. And that's why the packet has to go through multiple transmission delays. Because each time you have to store and forward, you have to retransmit, you have to regenerate the packet from binary to analog signal, from analog to binary signal, to digital, and so on. You have to do this. واضح? So you have to regenerate the packet every time. ماشي كده? So this is what we call store and forward. Is there any alternative? Yes. The hub does not store and forward. There's no store and forward. Hub deals with analog signal only. It receives a signal زي السبليتر كده. Okay? Receives a signal, forward the same signal forward. There's no store خالص. Even in switches, by the way, طبعا many of you will not remember. In network one, we studied what we call a fast forwarding. For switches, they have a mode of fast forwarding. So this is slightly similar to the hub. So the switch, it uses a mode of fast forwarding, in which case it doesn't store the packet خالص. So it forwards the signal right away. ماشي? So it works essentially similar to a hub. The good thing about that is that I don't have to regenerate the packet or convert it from digital to analog to digital, in which case I don't have to go through the transmission delay multiple times. Okay? طيب, let's see the effect of the statistical multiplexing. So as I said, if I have multiple users A and B, each of them are sending, they have data to send. But logically, by the way, each node doesn't send 24/7, صح? They send in times, and in other times they will be idle. Okay? The other person will send, and in other times it will be idle. صح? So that's why the packet switching is very efficient. Why? Because at some point you may be using the entire bandwidth for your traffic. In other times, you will share the bandwidth with others. ماشي. To the sequence of A and B packets has no fixed time patterns, in which case I don't use TDM or FDM. خلاص ما فيش. I don't need to do this. There's no dedicated circuit. I multiplex the packets in any way that I see appropriate. And usually we multiplex the packets on the shared medium and store the packets in the router using store and forward and process packet by packet. So if the collective traffic of the users is less than the capacity of the link, okay, the router doesn't need to store the packets in the queue for a long time. You will see the queue of the router is always empty. Okay? Because the collective data rate is not above the capacity of the channel or the capacity of the shared medium. هنشوف دلوقتي الكلام ده. طيب. So we'll go through very quick 2 exercises and then we'll close. So the first one, if I have the physical cable connected with a router, and then the physical cable connected with a router, and so on. Okay. If I want to calculate the total transmission delay end to end, okay, so of a packet of length L, what is the total transmission delay end to end? In that case, we said that the transmission delay is L over R, صح? But this is for one link, okay? If I have 3 links, don't be fast in this. You have to ask yourself one question. If the router uses store and forward, then what you're saying is true. If the router is actually a hub, what is that transmission delay? L over R بالظبط. There's no store. Okay? So essentially here I have L over R, and here I have L over R, and here I have why? Because every time this packet will have to be stored in the router and retransmitted. Retransmitted معناها I have to go through another transmission delay. Okay? But if this is a switch or a hub, in that case I don't need to store, which means I don't need to regenerate. صح? So it's an analog signal that goes all the way. So in that case it's only one L and R. L over R. واضح الفرق؟ ماشي. طيب. So this delay is طبعا هنا احنا we're ignoring another type of delay which we will talk about later, which we call a propagation delay. We'll talk about this. So essentially we have 4 types of delay. 4 types of delay that this packet goes through. So we'll study all these 4 types of delay next lecture inshallah. طيب, one last example, we'll close with this. So if I were to have n users, okay, on a shared medium that goes through the router, okay, and each user sends with a rate of 1 megabits per second. So if I tell you this information only, ماشي, only, and I tell you that using circuit switching, what is the maximum n? ماشي, assuming ان انا عندي هنا ايه, this is 1 megabits per second link, okay, and I have each user sends with a bit rate of 100 kilobits per second. Okay, if I use circuit switching, what is the maximum n? اللي هي ايه, 10 users, صح? So if I tell you circuit switching, هتقول لي على طول the maximum n is 10 users, and I have to divide this shared medium into 10 channels, either using TDM or FDM, and each channel will have a fixed data rate of 100 kilobits per second.
So we are doing in frequency.
طيب.
Don't you have like a safety margin or something? A frequency.
يا ماشي, السيفتي مارجن موجود, بس ده فيزيكال لاير ايشوز, مالناش دعوه, مش مشكله يعني. ماشي, هيكون في سيفتي, ماشي, مش مشكله. خلاص قسمت وعملت السيفتي وعملت جارد بانز وعملت الكلام ده، مش مشكله، ماشي تمام. فايف I use circuit switching the maximum n is 10. maximum n concurrent. I could have 8, could have 9, could have 7. But in any case, I will have to divide this shared medium into 10 channels using FDM or TDM. ماشي؟ عندي بقى 8، عندي 7، عندي طب لو عندي 11. If I have 11 users, لا مش طفلك خلاص. You cannot. Okay? Imagine بقى if each user is active 10% of the time. If each user is active 10% of the time. Then if I use circuit switching, I have 90% of 10 channels that are not utilized. صح? You see the issue, the big issue? طيب. Let's see بقى ايه in packet switching. What is the maximum n? I can't tell. Could be more than n. Could be more than 10. Okay? طيب هو هنا بيقول لك in this example بيقول لك طب what if n is 35 and each one is sending with a rate of 10 kilobits per second. ما ينفعش. 35 times 10 100 kilobits per second, that's a lot more than 1 megabits per second. Okay? لا ينفع. It works. Okay? لا we have to go through probabilities هنا بقى, unfortunately. So you have to refresh your probability and statistics course now. Okay? طيب. If I have 35 users, first I have something called probability of a user being active. We know that this is a layer 0.1. This is the probability of one user is active. Okay? What is bad? The probability that 1 out of 35 users active. هتقول لي what's the difference? لا, there is a big difference now. I have a pool of 35 students, 35 nodes or 35 users. I need to calculate the probability that only one of them is active. Okay? What is that probability now? ها؟ لا 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 لا. لا 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 لا. This is bad. The set theory. You have group of people, okay? They are tossing a coin with certain probability. So what is the probability that at certain time that this user produces a certain outcome? This is what we call binomial distribution. Binomial distribution talks about a group of people, okay? And each of them has certain probability to produce certain outcome, okay? So what is the probability that one user produces that outcome? A probability that one user produces this outcome معناها this user produces, يعني معناها this user is active, okay? And all the others are not. What is the probability that all others are not active?
0.9.
اللي هي ايه؟ 1 minus p صح؟ to the power معناها ايه؟ all the 23 other users are not active. All of them. Okay? معناها AND together. AND in probability معناها ايه؟ multiply. صح؟ So all of them are not, all the others are not active. And this one is active. Is that it? No. No. Why? Because this is the probability that specific user is active and the 23 others are not active. But this might change. Okay? So one user, يعني معناها user 1 is active and all the others are. User 2 is active and all others. Or user 3 is active and all others. Or in probability معناه ايه؟ Plus. Okay. How many combinations do you have? 35 C1 combination 1. Okay. So this is what we call a binomial distribution. So this is the probability that 1 out of the 35. So if I calculate the probability of 2 out of 35 نفس الشيء هيبقى 35 C2 probability P to the power 2 and 1 minus P to the power 22 and so on. Okay? طيب. What is the probability that I have more than 10 users out of 35 users are active? More than, not specifically 10. لا, it's actually 11 or 12 or 13. So I have to do this for 11, I have to do this for 13, for 14, for 16, and so on. All the way to that. All of them are active, which means P to the power 35. Huh? So this is a 35. More than 10 معناه 11. 35. C11, P11, 1 minus P to the power 35 minus 11. Plus 35, 12, P12, and so on. And you have to do this from 11 all the way to 35. Okay? If you calculate this, you will find a shocking result. The probability that more than 10 of these users are active concurrently is this. 0.0004. Okay? But if I have 35 users, I have a probability of 0.0004 that all of them are sending at this, all of them are sending at the same time, which is a very, very likely scenario. طيب. Even if I have this scenario, I'm going further with this. Even if I have this scenario, this small probability, do you have a mitigation for this? Yes. What is it? Huh? Buffering, bravo. So I can overcome this by router buffering, which means I will have to go through congestion. ماشي? Congestion, I can mitigate congestion? Yes, you can mitigate congestion. To some extent, يعني not ما تقوليش congestion can be mitigated 100% of the time. No. يعني ولذلك 100% scalability cannot be achieved. Okay? يعني Google and Apple, they have some downtime for their systems. Scalable, when I say a system is scalable, there is always a limit. I cannot guarantee 100% scalability or 100% reliability. ماشي? That's not achievable. But at least I hope you appreciate now that this is much more scalable compared to circuit switching, where I have a maximum number of users 10, and not only that, many channels can go idle, and even the channel that you're using might have some idle time. You see the issues here? ماشي? But here I can increase more than 10 freely. Eh?
How can I test the limit?
The limit بقى depends on many factors. ماشي? It's not something that we can calculate easily. In order to calculate the limit, you have to give me a fixed network infrastructure and the size of the buffers on the router, on each router, in the entire core network. Okay? And the statistical distribution of the users who are sending from each and every location. Okay? And fix everything then I can calculate I can give you some boundaries on the limit. ماشي? So I can calculate the limit in very specific configurations, but you have endless configurations here. يعني it's not something that you can calculate for all scenarios. يعني. You have to fix the scenario. Any questions? Enough today? كفاية؟